Good day, my name is Maura Caro, and this presentation details the complete development of supervised machine learning pintle designed to predict the bank client subscription to the term deposit. Working with the bank marketing dataset sourced from Kangol, we analyzed over 41,000 samples contain 21 mixed variables. Our primary objective was to construct a transparent and reproducible model comparable of binary classification, specificity, distinguishing between claims we will say yes to a deposit and those who will say no. However, raw actuality was not our only metric. We needed a model robust enough to handle the economic realities of real-world marketing campaign. Upon initial inspection, we identified the project's different challenge as severe class imbalance. The target variable distribution reveals that 89% of clients reject the offer, while only 11% accept. This disparity implies that a naive model could simply predict the majority class of every client and appear accurate, yet fail entirely of indefinitely a single subscriber. Furthermore, our diagnostic revealed that while non-subscribers are physically distinct and easy or classified, the target just population is highly absolute, ambiguous, and overlaps significantly with the null group. This interesting nice represent the true classification difficulty we had to overcome. To contact this bias and prioritize the minority class, we implemented random undersampling on the training set. We reduced the majority class count to match the minority class, forcing the algorithm to learn from balanced 50-50 distribution. We accepted the trade-off that losing majority class variance would likely reduce specificity in exchange for gaining the sensibility required. Simultaneously, to handle dimensionality, we exploit lasso regression and Kami analytics. We successfully reduced the noise by narrative the input down to just 10 key variables. Moving to our results on the ANSYS test set, we evaluated logistic regression, random forest, and XGBoost. The XGBoost classifier emerged as the superior model of deployment, while it delivered an comparative accuracy of roughly 85%. Most importantly, It achieved a sensibility of 92%. This is the critical operational metric. A sensibility of over 90% confirm that we are susceptibility in the feeling the vast majority of potential subscriptions. We have effectively mindset false negatives, and ensuring the bank does not miss out on high value opportunity, fulfilling the primary business objective. However, we must address the limitations of this approach. Our analytics confirms several overfitting in the three basis models. We observe a performance gap approximately 15% between the trained scores, which were near perfect, and the testing scores. This instability is the cost of our downsampling strategy. We discarded nearly 7-8% of the training data to achieve balances. We restricted the model's ability to learn generalistic patterns. Concurrently, the immediate next step is rigorous hyperparameter tuning to sensibly the decision vulnerability and close this generalization gap. In conclusion, despite the trade-offs regarding stability, the project has succeeded in its core mission by combining feature selection with random undersampling. We developed an XGBoost model that preceded the memory class effectively. We have moved from a basic dataset to strategic to the capture over 90% of potential subscription. This model is now ready for optimization and deployment, providing a robust formation for target marketing campaigns. And this is my presentation of machine learning. Thank you for your attention.